As we expand our look at quadrilaterals beyond parallelograms, we're going to look at some special parallelograms that are used often. So in this lesson, we're going to be talking about properties of rhombuses, rectangles, and squares. Now, each of these have similar qualities to one another, and the best way to diagram that is with the Venn diagram. The first is our rhombuses. Now, a rhombus has all four sides being congruent. And rhombuses are often referred to as diamonds, but in geometry there is no official definition of what a diamond would look like. Our next special parallelogram are rectangles. Now, a rectangle has the quality that all four of its angles are congruent. And since the sum of the interior angles of a quadrilateral is 360 degrees, that means that all four angles are 90-degree right angles. Now, in the overlap section of rhombuses and rectangles, we find squares. And as the Venn diagram shows, the square category shares the qualities of both the rhombus and the rectangle. So not only do we have four congruent sides, but we also have four congruent angles. And this lesson is just going to look at the properties that come in with either of those qualities, the sides or the angles, and understand that squares will have both sets of qualifications. So we're going to be looking at a few more theorems as we go through this. Let's begin with Theorem 613. This one states that if a parallelogram is a rhombus, then the diagonals are perpendicular. Theorem 614 tells us if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So now, as we use these two theorems, we can solve for the missing angles in the diagrams shown below. So in the first diagram here, we know that angle Q is 104 degrees. What we need to do is find all the others. Well, knowing that these are rhombuses, we know that the four sides are congruent. Since the four sides are congruent, we can use our isosceles triangle theorems to know that angles 1 and 3 are congruent to one another as well. So we take our 180, subtract the 104, and that gives us 76 degrees. Angle 1 plus angle 3 equals that 76. So the measure of angle 1 is equal to the measure of angle 3, and both of them total 76 degrees, making each one 38 degrees. Now, how do we use this to find angles 2 and 4? Well, according to Theorem 614, the diagonals bisect opposite angles. So angle 1 is going to be congruent to angle 2. Angle 3 will also be congruent to angle 4. So all four angles are equal to each other. So all of them equal 38 degrees. Now let's look at our second figure. What we are told in this one is that angle ABD is 58 degrees, and we need to find all these others. Well, using Theorem 614, we know that angles 3 and 2 are congruent to each other, and they're bisected just as what we have up here around angle B area is. So the measure of angle 2 is equal to the measure of angle 3, which is, for both of them, 58 degrees, same as what was given. Now we need to find angles 1 and 4. Well, from Theorem 613, we know that the diagonals are perpendicular. That means this intersection here where angle 1 is located at, the measure of angle 1 is 90 degrees because that is the definition of perpendicular. Then using our triangle angle sum theorem, angle 1 is 90 degrees, angle 3 is 58, so the measure of angle 4 plus 90 degrees, which is the measure of angle 1, plus 58 degrees, which is the measure of angle 3, has to equal 180 degrees. So measure of angle 4 plus 148 degrees is 180. Using our subtraction property of equality, we'll subtract 148 degrees from each side, giving us that the measure of angle 4 is equal to 32 degrees. So with rhombuses, if we're given just a little bit of information, we can find much more out there. There are also theorems and properties that come into effect when we start looking at rectangles. Theorem 615 is one, and it tells us that if a parallelogram is a rectangle, then its diagonals are congruent, meaning that in the diagram that is shown, each of the diagonals are going to be congruent to each other at the same length. So if ln is given to us as 4x minus 17, and mo is given to us as 2x plus 13, and if I needed to find the length of either of those diagonals, I would solve based on the fact that these are congruent. So if I take my ln and set it equal to mo, I would have 4x minus 17 is equal to 2x plus 13. Subtraction property of equality tells me that 2x minus 17 equals 13. Addition property of equality tells me that 2x equals 30. Then using the division property of equality, x equals 15. So if x is 15, substituting that back in, ln is equal to 4 times 15 minus 17. 4 times 15 is 60. 60 minus 17 is 43. So the length of ln is 43 units, but the length of mo is also 43 units. Now, what type of triangle could we form with MPL? Knowing that P is a midpoint, that tells us that MP is congruent to LP, and with those two congruent sides, not knowing the length of ML, we would know that this is an isosceles triangle. So again, with rectangles, we can have additional properties being added in. Take these properties for both the rhombuses and the rectangles, and the squares would show both attributes. Not only are the angles on the corners going to be bisected and the diagonals be congruent, but the diagonals will meet at a perpendicular point 90 degrees to each other. So all these will work together as we move forward in our study here of quadrilaterals.